Andy, I wanted to, so under the bolt pretension, you can, in the results, you can look at the adjustment and how do you, so how do you use a hand calc to look at that adjustment and say, okay, this makes sense, or this doesn't make sense. So if you could
Right,
talk
right.
about that. You could talk about, that value, if you want to show that value in the model and then, compare it to your hand calc or vice versa, whichever. Maybe the hand calc you should do first.
Sure, sure. Yeah, and it's a great question. When you plot the deformation in ANSYS, you'll see a discontinuity in the bolt, and you're like, oh, where's that coming from? And it comes from ANSYS has a pretty novel way of modeling bolt pretension to clamp the flange together. So if we were to imagine a bolt, so this is a bolt right here. And ANSYS cuts this. It cuts a small delta L from that bolt, and that delta L is nothing but FL over EA, which comes from the statics class. So what that's stating is that F is the preload of the bolt, L is the length of the bolt that's preloaded, and then E is the elastic modulus of the bolt, and A is the area of the bolt. The delta L is how much material that ANSYS removes from the bolt to model the clamping to get that force.
And what is the L you use in that calculation? What is the length?
Okay, the L represents the so whatever part of the bolt is modeled in ANSYS as having the preload, like where it's applied, that's the L.
And then it's going to put it over, but it's going to put that preload over that entire, because you're applying the
Yes,
preload to a face.
that's correct.
But it puts a strain on the entire part. Is that, because it's a strain, right? It's essentially, it's modeled as a strain.
Right,
Uh,
right.
I,
So,
with an analogy to thermal strain, which is also something we put into this model.
exactly. So like if the bolt were considered to be like a spring at rest, and we were to clip a little bit of it here, a little bit of it there, and then glue them together or solder them together, then the spring is now wants to pull my hands together.
Yes.
And if my hands are analogous to the flange, it wants to pull the flange together and then keep it tight.
But you put the preload only over the region in your model. You put it over the
Yes,
region where you basically have the threads, right?
that's exactly right. And so in the model, there has to be a location along the shank or the threads where it's bonded to the nut, and then the remainder, there's two faces. The remainder, the preload is applied to that. Now, it's somewhat arbitrary, like where that line is set. Typically, as long as more than half of the bolt length is available to apply that preload, you're fine.
Okay. Okay. And so we will check that, we'll use that formula to check if the adjustment we get from ANSYS
Yes,
is
right.
matches that. So
Yeah, and certainly
we'll do
some
that
some
in this.
students that are on the racing team will be like, well, I have my bolt, and then there's a shank. There could be a shank section and a thread section, and the threads are complicated in shape. So what do I use as my actual area? Is it actually capturing all the details like the FEA? No, the FEA it will capture the effective preload from that bolt, and it'll do it well. FEA only does like a partial job on, well, what's the bolt capable of doing? Because we would actually have to model like the minor area of the bolt if we wanted to do it exactly right. But it's better to just to do a hand calc on the bolt to get all those details out. For this type of problem, it's okay.
Thanks for explaining that.